Life's got problems, let's find solutions. Part C, we are asked to calculate what volume of carbon dioxide gas is produced after it's collected and dried. What would it be at STP, standard temperature and pressure? It doesn't say what units to report it in, so we could report it in any units, and liters is probably the most logical one that we're going to use. We know that we have 15.0 grams of zinc carbonate that we've started with. That is a measured value, so that does count for our sig figs. And we need to convert that then first to how many moles of zinc carbonate we're actually using. Then we're going to do some stoichiometry. Hope you remember that. And after we do some stoichiometry, we'll find out how many moles of carbon dioxide are produced. For every 1 mole of zinc carbonate that goes into this reaction, 1 mole of carbon dioxide is going to be produced. And then because we're told it's at STP, then that means we can use the molar volume conversion of 22.4 liters is equal to 1 mole. For every mole of gas you have at STP conditions, doesn't matter what chemical it is, it will take up 22.4 liters. That also is a measured value. I think it's like 22.39 something. I don't know for sure. But that's also a measured value. It could be more precise than that, but this is what you use in class, and this is what's on the AP exams equation sheet. So you're held to these 3 sig figs here. So we got 3 sig figs in this measured value and 3 sig figs there. Our molar mass is also something that counts for sig figs because we have arbitrarily decided to round it to the tenths place. So really, we could be more precise than 125.4 in our calculated value, but we're not. We're taking it to the tenths place only. So this has 4 sig figs when it comes to multiplication division. So let's go ahead and run through this. We're going to go through this quick. Hopefully you do remember how to do this, and later on in the course we will go through this a little bit more thoroughly, but we've got 15.0 grams of your zinc carbonate. We're going to convert that by dividing by its molar mass. 125.4 grams for every 1 mole. Notice molar mass is a conversion factor, and so with dimensional analysis we can see grams and grams are going to cancel. If we stopped right here, we would be at moles of zinc carbonate. Continuing on, for every 1 mole of zinc carbonate, this is our stoichiometry step, we produce 1 mole of carbon dioxide. If I stop the problem right now, grams of zinc carbonate would cancel, moles of zinc carbonate would cancel. If I stopped right here and just calculated this out, I would know how many moles of carbon dioxide gas I've produced. One more thing though that has to be done is let's convert that to a volume. For every 1 mole of my CO2, I'm going to have 22.4 liters of volume. There is the entire setup of the problem. I'll spare you the button pushing again. If I calculate this out for a raw answer, I'm getting 2.67942, etc. And so with sig figs, we've got 3 sig figs in our zinc carbonate gram value. We've got 3 sig figs in our molar conversion, and we've got 4 in our molar mass. And since this is all multiplication division, then we need to round it to 3 sig figs. So we're rounding at this spot here. That 9 bumps that up. So we are going to have 2.68 liters to report as our volume of carbon dioxide. In theory, this is the most that we should be able to collect from this reaction. Now that's good review of stoichiometry, but keep in mind the point of this video is to show you why naming is important. Would I have gotten this answer if my formula for zinc carbonate was wrong? No, I would not have. The value of the molar mass would be different, and possibly my stoichiometry might be different too. So I would not have the same coefficients. I would not have gotten this value. The most I could get then would probably be 3 points if my sig figs were correct and if I still showed liters and I showed all of my logical work that I was trying. So this could be a 3 out of 5 point question too if I didn't know naming. And we have to use this value now in Part D. Let's take a look. Part D tells us that if we actually collected 2.10 liters of carbon dioxide gas, what would be our percent yield? Percent yield is something that you actually calculate whenever you find your grade. You know, you get the points back as far as how many you earned and divided by the number of points your test or quiz was out of. You find that percentage, you're finding a percent yield, the percent yield of points you earned on that quiz or test. So we can do that also with chemicals, with the mass or with the volume. It doesn't matter as long as the units of actual yield and theoretical yield match up, because then they cancel out. So if I have 2.10 liters, well, that's my actual yield. That's what I actually collected. My theoretical yield is what I got in the previous problem, this 2.68 liters. The thing is, though, we are about to plug that into an equation where we're just going to divide by that value. So really, we should not use this rounded number. We got to use the raw number. Now, I kept it still here in my calculator, so I'm ready to go with that. I can just store that in my calculator and divide by that value in the equation. So this is the raw value, 2.67942. If you didn't store it in your calculator, always write down your raw value, just long enough sig figs in there so that way you know that you're pretty safe. I could plug just this number in there instead of everything that's on my calculator and still be sure that I'm getting a close enough answer to where it's not causing me any problems. So my percent yield then is going to be 2.10 liters divided by 2.67942 and some other odd change. And I have to multiply that by 100 to get the percentage. Made a mistake, sorry. Calculating this out gives me 78.375 as a raw value here. So rounded to 1, 2, 3 sig figs, and this number also had to be rounded to 3 sig figs because of where we got it from in the previous problem. This is going to be 78.4%. Another 5-point problem. Yes, that percent sign is our unit, and that counts for our unit point. And again, if I had the theoretical yield wrong from the previous problem, then this number would also be wrong. And I could have gotten this number wrong from the previous problem if my zinc carbonate formula was not correct. So that could have also cost me 2 points on this one. If I didn't get that zinc carbonate formula correct, this would probably also be just 3 out of 5 points if you got the other 3 points for sig figs work in units. So maybe this will drive it home for you why naming is important. Let's look at how many points you would have gotten if zinc carbonate hadn't been the correct formula. Write the balanced chemical equation for the process. We already showed you that you would have gotten 0 out of 5 on that one. Calculate the molar mass of zinc carbonate. As long as you showed your work, the sig figs were right, and you got the correct units, you'd have 3 out of 5 on that. If the carbon dioxide gas is collected, tell us what the volume, theoretical volume is. That would have been a 3 out of 5. And we said for part D, 3 out of 5. Altogether, that's just 9 out of 20 points. Naming is important. Learn your naming. Here's some other videos that you could check out. And I hope you understand how important naming is. Hey, by the way, do you know this one? Pop quiz. Did you say copper sulfate? If you did, sorry, you got to call this guy copper 2 sulfate. All right, we'll see you next time.